He was also an intern, and he's done an amazing job. Welcome, Rohit. Looking very sharp.
Thank you. Yeah, I'll just go ahead and then share my screen.
Yes, please.
All right. Hello, everyone. My name is Hello, everyone. My name is Rohit. I'm a recent graduate from Central Bucks South High School, and I'm an incoming freshman at Rowan University. And my paper was about oncolytic viruses, an overall review of oncolytic viruses and how they can serve to be a viable option to treat cancer in the future. Before we get into everything, I just wanted to talk about a few things. So just wanted to talk about what my paper is about, so the research questions, so what were the objectives. So my paper is pretty much about understanding the mechanisms behind oncolytic viruses and their viability in clinical settings for its use as a cancer immunotherapy. And the specific questions I was researching about were the mechanisms of oncolytic viruses, the advantages and limitations that these viruses have currently, and the use of these viruses today to treat different types of cancers and what it could mean for the future of immunotherapies. So for my objectives, I just wanted to learn more about oncolytic viruses and why they were so intriguing in the world of immunotherapies and what it could mean to have a reliable virus that's able to go ahead and target a spectrum of different cancers. And I also wanted to understand more about the limitations the oncolytic viruses have currently that prevent them from reaching their promise that scientists see. So before I go into my results, I'd like to talk about what current literature is saying and what they're doing. So currently, scientists are trying to find different characteristics between healthy cells and cancer cells. As you can see here on the left, I just listed some different characteristics like the shape, how many nucleoluses there are, and how many and the types of suppressor genes and the different genes that are being expressed by each of the cancer cells. And with that, they're looking mainly at aberrant pathways, which are just pathways that are different from healthy cells. So that allows for viral replication, and then for specific surface protein and surface receptors that are overexpressed in cancer cells compared to healthy cells. And I was also looking at approved viruses right now. So that's the TVEC and G47 Delta viruses. And then just looking at oncolytic viruses that are genetically modified from wild strains to strains that we can inject into patients to target cancer cells. So the results of my findings were that oncolytic viruses can take advantage of the differences we observed from prior studies comparing cancer cells to healthy cells, like the aberrant pathways and the surface proteins and receptors. And using receptors like EGFR, which is the epidermal growth factor receptor, oncolytic viruses can enter the cell to replicate. And in the case that oncolytic viruses do enter a healthy cell, functioning P53 pathways and PRK and IFN, or interferon signaling pathways, will keep the healthy cell from sustaining great harm from the viral infection, while cancer cells will have damaged defense mechanisms against viruses, so they'd be unable to protect themselves from these oncolytic viruses. And using the central dogma, oncolytic viruses can produce viral progeny, and this progeny accumulates until the cell lysis, hence the lytic part of oncolytic viruses. And then once these viruses lyse, you would see that there are anti-tumors antigens that are spread into the bloodstream, and that can allow the immune system to go ahead and recognize more cancer cells, hence the immunotherapy part of oncolytic viruses. And the most significant findings among all of these findings is that the immune system, which was prior unable to identify cancer can now become aware of cancer cells by introducing the presence of viruses. So you have an infection in cancer cells, and the immune system can recognize that. And by using antigens or antigens that are released into the bloodstream from cancer lysis, they'd be able to now recognize and go and attack and target cancer cells. And it's also important that oncolytic viruses are not harmful to healthy cells. So that means that we can use it as a way to cure or treat cancer without having too many side effects. It's known that these viruses don't have a high toxicity and they don't show any adverse effects, which is also important because if they did, then they wouldn't be able to be administered to patients. So in conclusion, I'd just like to talk about some limitations of them. So oncolytic viruses are limited to the specific surface receptors and pathways they can take advantage of. And that can be a problem because cancer cells can have random mutation rates up to 100 times that of normal tissue from the same patient. And because of that, overall direct lysing of oncolytic viruses will decrease, and the immune system will not become aware of those cancer cells because the virus is not able to find those cancer cells. And also, damage to cancer cell DNA can also damage the translation machinery that the virus will use to replicate. And these new viruses may show characteristics that are not desired and make new viral progeny that are ineffective to its oncolytic effects. So overall, answering my question, can oncolytic viruses serve as a viable option to treat cancer? And the findings of my research conclude that oncolytic viruses can find certain types of cancer cells throughout the body. They can also find cancer cells that are both benign and malignant, which is the main appeal of oncolytic viruses, given that they do have the correct information to do so. They also are limited to specific receptors and pathways that I mentioned before that they can exploit. However, we can find more ways to target cancer cells by continuing to understand more about the cancer environment. And